What do you know about Spider-Man?
Peter Parker actually changes into Spider-Man.
So are Peter Parker and Spider-Man the same person?
Yes.
Now, can Peter Parker shoot spider webs out of his wrists?
Yes.
Can he climb buildings?
Yes.
So Peter Parker can do everything Spider-Man can do?
Yes.
Well, then what's the difference between Peter Parker and Spider-Man?
That Peter Parker has skin and Spider-Man sort of like has skin.
Oh, yeah?
Yeah.
All right, now tell me about Superman.
Superman,
Yeah.
he can x-ray through walls and he can ice stuff and he can fly.
Oh. Now, does Superman have another name?
Clark Kent.
Clark Kent.
Clark Kent.
Oh. And can Clark Kent fly?
Yes.
Yes. Does he have x-ray vision?
Yes.
Yes. So, do they have the same identity?
Yes.
Just different names?
Yes.
But they're the same person?
Yes.
So we're going to talk about the fundamental identities for trig. Our objective, students will use the fundamental trig identities to solve problems. So let's review some of the identities that we already know. We know that cotangent is the reciprocal of tangent, so it's 1 over tangent theta. We know that secant is the reciprocal of cosine, so it's 1 over cosine theta. And we know that cosecant is the reciprocal of sine, so we have 1 over sine theta. Then we have our quotient identities, and remember that quotients are just division problems. So we have tangent, and the identity for tangent is going to be sine over cosine. And then our quotient identity for cotangent is just the reciprocal of the quotient identity for tangent. So we have cosine theta over sine theta. Now let's take a look at our Pythagorean identities. Remember, with Pythagorean theorem, we have a squared plus b squared equals c squared. And on the unit circle, that c squared is the radius, which is 1. So we had x squared plus y squared equals 1 squared, which is just 1. Well, remember that x squared is cosine squared, and then y squared is sine squared. So sine squared plus cosine squared is just equal to 1. And then by using some manipulations of that same formula, you can find that tangent squared theta plus 1 is equal to secant squared theta. And we'll talk about how we can get to that in class on Monday. And we'll talk about how we can get to that in class. 1 plus cotangent squared theta is equal to cosecant squared theta. Now let's take a look at our negative angle identities. Sine of negative theta is equal to negative sine theta. And if you look at the sine curve, if you have negative 45 degree angle, that's going to be the sine of 45 with a negative in front. It's going to be the opposite of the sine of 45 because that is an odd function. And then because it's reciprocal, because cosecant is the reciprocal of sine, then that's also going to be an odd function. Now cosine is an even function, which means it's reflective over the y-axis. So cosine of negative theta is the same thing as cosine of positive theta. And then because secant is the reciprocal of cosine, it is also an even function. And then tangent is an odd function. So tangent of negative theta is equal to negative tangent theta. And then same thing with cotangent because it's the reciprocal of tangent. So we have negative cotangent theta. Now let's take some of these identities and apply them in a problem. Example number 1. If sine theta equals negative 7/12 and theta is in quadrant 3, find each function value. So let's take a look. We know we're in quadrant 3, and we know we have negative 7 and 12. Now we could use Pythagorean Theorem and solve it that way, but let's try using our identities and see how that works. So if we know sine, and we're trying to find cosine, we can use our Pythagorean identity. All right, so we know sine is negative 7/12. And we're trying to find cosine. So we can square our negative 7/12, and we get 49 over 144. Then we can subtract that from 1 to get the cosine squared by itself. And we get 95 over 144. Then the next step, because we want to get cosine, and we have cosine squared, is to take the square root. Remember, when you take the square root, you need your plus or minus, okay? That becomes very important at this point because now we need to remember which quadrant we're in. We're looking at cosine, and we're in quadrant 3. So is our cosine value in quadrant 3 going to be positive or negative? Well, it's going to be negative. And when you take the square root of 95, that's not going to simplify. But then we can take the square root of 144, and that becomes 12. So our cosine of theta is negative square root of 95 over 12. Now let's try cosecant. Cosecant of negative theta. Well, first of all, we know cosecant of negative theta is equal to negative cosecant of theta. Okay? Then we also know that cosecant is the reciprocal of sine. So that's the same thing as negative 1 over sine theta. And then we know what sine theta is. So we have negative 1 divided by negative 7/12. Well, how do you divide by a fraction? You multiply by the reciprocal. And we have two negatives here, and the reciprocal of 7/12 is 12/7. So the cosecant of negative theta is 12 over 7. Now let's take a look at cotangent. Cotangent can be rewritten in a couple of different ways. You could make it cosine over sine. You could also do some other things, but this is going to be the easiest one to use because we've already found the cosine value. We knew that the cosine value is negative square root of 95 over 12. And the sine value was given to us in the original problem, negative 7/12. Well, we have two negatives, so that makes it a positive. And they both have a denominator of 12. So our answer is square root of 95 over 7. And that's going to be your cotangent of theta. All right, let's try example number 2. Express sine of x in terms of cotangent x. Well, there are several identities we can use. I'm going to use a Pythagorean identity because there's one that involves cotangent and the reciprocal of sine. So we have 1 plus cotangent squared of x equals cosecant squared of x. We know cosecant is the same thing as 1 over sine. And if the cosecant was squared, then the sine has to be squared. Then we can also say, okay, well, that's the same thing as 1 plus cotangent squared over 1. So what we can do is flip both of the expressions because they'll still be equal to each other. And that's something that we learned back in algebra. So now we have sine squared by itself, and it's in the numerator. So the last thing that we need to do is take the square root of the sine squared. They must be working on something downstairs. All right, so then we take the square root of both sides. Remember, when you take the square root of both sides, you have to have the plus or minus. And so that's going to get your sine by itself, so it no longer has the square. Let's move this up just a tad. And then you have plus or minus. You have plus or minus the square root of 1 over 1 plus cotangent squared x equals sine of x. So now you have expressed sine of x in terms of cotangent. All right, let's try one more. Example 3. Express 1 plus tangent squared theta over 1 plus cotangent squared theta in terms of sine and cosine, and then simplify the expression. Okay, be very careful. A lot of people want to make the mistake of canceling out the 1 and the 1, and then the tangent squared and the cotangent squared. But you can't do that because those are both addition there. So you can't simplify that way. So we have to look at some identities that might be able to be used. All right, so first, 1 plus tangent squared theta, we know that equals secant squared theta. And then 1 plus cotangent squared theta, we know is equal to cosecant squared theta. Well, now we can take those and represent them in terms of sine and cosine. Remember that secant is the same thing as 1 over cosine. And then cosecant is 1 over sine. All right, and how do we divide by a fraction? Multiply by the reciprocal. So your answer is sine squared theta over cosine squared theta. Now it said to express it in terms of sine and cosine, so we're done. But if it didn't, we could take it one step further because we know sine over cosine is the same thing as tangent. So that whole expression actually equals tangent squared theta. But our answer is the sine squared theta over cosine squared theta because they asked us to express it in terms of sine and cosine. And that's your basic introduction to fundamental identities for trig functions.